This is a guide to chemical reaction notation. So what I have here is a generic chemical reaction, and there's many aspects that are hidden in this. We like to be as efficient as possible, not have to use as many words. But it's really important to be able to know what each of these things mean. So we're going to go over the larger meaning of this first and then start parsing down the details. So you'll notice that there's an arrow here. The arrow separates the two sides of the reaction. Most of the arrows that you have seen up until now are single-headed arrows that go from left to right. This means that your reaction goes to completion. That means that basically you start out with something, you end up with something else. Later on in the year, we'll encounter double-headed arrows, arrows that go both ways, and we will talk about that later, but understand that the arrow, whichever way it's going, single-headed or double-headed, separates what I start out with what I end up with. So what's on the left-hand side are my reactants. They're the starting materials. It's what I put into my reaction vessel, or you can think of it as the starting materials that you have in a recipe. As the reaction proceeds, however quickly it proceeds, it could be slow, it could be fast, as I do that, I create my products or my end result. So again, if we're thinking about the recipe, it would be the cake that you end up with, or the soup that you end up from the reactant, the starting material. So my products usually do not resemble my reactants in any way, and those are my products. So I have here in black my reactants, and here in light blue my products. So I have two reactants on both sides. You can have any number, it depends on the reaction itself. I have two here and two on this side. So I use the symbols that are found on the periodic table, and remember that anytime you have a different capital letter, it's a different element. So this one is just made up of an element. This is a compound, and then it's going to create another element and another compound. So another thing that you'll notice is that there are, in green, little subscripts of letters in parentheses after each reactant or product. So those are the states of matter, and they are the states of matter at room temperature. It doesn't matter if the reaction normally occurs in really cold temperatures or really hot temperatures. We write down the states of matter as if they were at room temperature. Lowercase g stands for gas, lowercase l stands for liquid, lowercase s stands for solid, and AQ stands for aqueous, which means dissolved in water. You have to use lowercase letters for the states of matter. It's a rule. I wasn't even there when they voted on it. We just have to accept. I use this fancy L, script L for liquid, just because it makes it easier to see that as an L rather than as a 1. So again, states of matter, we put them in when we know them. Sometimes you don't. But the 4 states of matter that we will be working with are gas, liquid, solid, and aqueous. So you'll see here in our reaction up here, I have 2 different states of matter. 2 of them are solids, and 2 of them are aqueous or dissolved in water. I also have subscripts that are numbers, these pink things. These things will tell you how many atoms or cluster of atoms, if they're in parentheses, are needed in the compound. So this compound right here needs 3 oxygens, and if there is no subscript, we just assume to be 1. 1 nitrogen and 1 silver, and that creates that special compound. This one requires that 1 nitrogen and 3 oxygens, but actually in sets of 2. So when they are in parentheses, they function as if they are a unit in that set of 2. So if I'm looking at like bicycle wheels on a bicycle, I don't talk about each of the spokes and the tire and the rim. I think of that as one single unit, just a wheel. So NO3 would be like a wheel. And then finally what you have is you have large numbers that are at the front of the elements or the compounds. I like to box these simply because it makes it easier for them to stand out. These are the coefficients, and they tell you how many of the entire compound is needed in the reaction. to have what is called balanced reaction. And we'll talk about how to balance reactions afterwards. One note, we don't use the number 1 either as a coefficient or a subscript if there is no number, either as a coefficient, like in front of copper here, or 1 as a subscript here, as in after the silver or the nitrogen. We just assume that it means 1.